Hello, my name is Zachariah Birch, and I'm team captain of Team 9. Sadly, today none of my team members were able to make it, so I will be the one presenting to all of you. Do you guys remember the wildfires that occurred last year, the terrible wildfires? Well, that's the problem. Reoccurring year by year, New Mexico has lots and lots of wildfire where lots of land burns. Pretty much our project last year. Yeah.
Can you move over?
Yeah.
You can block the poster, but I want to see. Sorry for interrupting.
But our project last year was a robotic air quality monitoring system in Snoopy. Whenever those terrible wildfires occurred, we decided to test Snoopy, and we got these readings, which were very high. Like that was outside. Imagine inside an enclosed space with those readings, you would get up to 1,000, which is terrible. These are the internals of Snoopy. And last year, we had worked with a different mentor and made AI to determine the correlations between different data points. So pretty much we did a variety of tests to determine how accurate our Snoopy was and to determine pretty much the cause and effect based on situation and how well the air quality would be. This leads us to today's project, Smokey, the robotic wildfire detection system. Smokey has a CO2 sensor, a TVOC sensor, a smoke particle sensor, and an infrared sensor which can detect flames. Basically, you'll see it. Smokey was coded in several lines of C++. Here are a few examples. Pretty much we have a watchdog timer, so in case Smokey freezes, it won't be just stuck for hours and unreliable. It'll reset itself and then it'll be good to go. We have the LED code displayed. If you look, there's warning LEDs. So it also has a temperature and humidity module. So whenever the temperature gets too high and humidity super low, it will alert the user for that. And then it detects whenever the smoke gets too dangerous. And then, of course, we have it connected to our app currently. I'll go around and show you. And wanted me to show it to Ken?
Yeah, if you can just have me the logo bar, put it up in front of us.
Here's some data that we took while doing various tests on Smokey. Pretty much we tested each of the different modules. The only one that was unreliable was the CO2, likely due to a glitch or where we have to replace it. Otherwise, all of the error modules we found to be accurate. So if you look, here's different graphs. We did a flame test in pretty much our science teacher's fume hood. We did a few different tests. We also did a light test and distance test. But surprisingly enough, we were able to get it 90 feet to detect, like up to 90 feet, but we could have likely gotten it farther if we had a place to actually put the little space heater we were using for light. And if you're wondering why it's limited at 99, that's because we were limited on the amount of characters for the display in the app and on the display. And then here's the light test. So we did different light tests to show that the infrared light sensors are affected by any of them. And here's there's a parabolic, or not parabolic, there's a candle. And then here's the space heater we used. Pretty much we were able to accurately detect pretty much when there would be wildfire conditions and when there would be flames present. Pretty much what we would do differently is add a more reliable CO2 module, as I've explained, add a wind strength sensor, wind direction sensor, and also waterproof it and then get PV panels. And then what we would do is mass produce them, like ideally, and connect them in the network. Are there any questions? Yes.
Did you see a difference between the candle and using the infrared heater?
For the smoke levels, we did see a difference because, of course, the candle had smoke, whereas the space heater didn't. So on that sensor we did, For the heat sensor, we also did whenever we tested it like different heat. So whenever it was closer, of course, the temperature sensor will go up. Mostly we were unable to because again, we're limited on characters. That's why pretty much we're able to detect up to 99, which proves that there's a fire present. Whereas the actual physical sensor itself can detect way higher.
So you feel like the infrared view is a useful, it's not a fire.
Yeah, no, so pretty much it was a test. And an actual fire would be able to detect way farther than 90 feet.
So do you plan to change the app to give you more higher resolution, higher values on the app?
Pretty much we're using the app based on a Bluetooth module. Ideally, what we would do is make our own app, and then it would allow us to have more characters displayed.
How did you guys settle on a parabolic reflector for that IR sensor?
So the parabolic dish, pretty much we were inspired by like satellites designs that have like IR sensors, and pretty much usually in their designs they have a dish, parabolic dish at that, in order to pretty much improve what it's seeing. Whereas the sensor won't see as far, but due to the parabolic dish, it allows it to see farther.
Okay. And then with that added sensitivity, do you think there's a chance you'd be able to detect wildlife or something that could be affected by wildfires?
You mean as pretty much it would detect the infrared light off them, or
Yes.
it won't be able to, as it's only searching for pretty much for pure infrared light. So not like pretty much, for example, me and you, it won't detect that, but an actual fire, it will detect that.
So your limitation on number of characters, are those characters restricted to just numbers, or could you use something else? I mean, could you translate that into an alphanumeric code, which would allow you to, in the same
Yes.
number of characters, think about going to a hexadecimal, sorry.
Yeah, we would be
those
able
sorts
to
of
do that.
things.
Yes.
Have you thought about those sorts of things?
Those sorts of things would work. However, pretty much for easy use, like when we're monitoring, or for example, say someone doesn't know hexadecimal,
Yeah.
for just so it's easier to display, we used 99.
Yeah, but
If it
if it
is
showed
like,
me ZZZ, I might
Yeah.
think that's really high.
Yes.
I'm just thinking about another option that would allow you to use the same app and the
Yeah.
same display, but they're doing it in a slightly different way.
yeah, that's a possibility.
Okay.
And pretty much these are each of the different versions of Smoky. Pretty much each version we went through. This is a basic one, no display, no infrared sensor. Then we went to the second version, the LCD display, which I don't have my app connected to it, that's why it's not displaying anything. And then the LED lights, of course, so we decided it'd be easier to see. It'd be easier to see them on one side. Hence why on this version, so far the final prototype that we have so far, it has them on the front. And this one also has the infrared sensor.
Yeah, so this, so come for your fire detection application. Have you thought about what distance you need to be able to detect in order for it to be useful, sort of good enough?
So pretty much so far with this current infrared sensor, it's able to, what we tested, 90 feet with a bigger infrared like source, or even a flame for that matter. It'll detect farther, and pretty much as goes on, the bigger the flame, the farther it can detect. Whereas we could, if this was mass produced and such, in order to keep costs down, you could get a better infrared sensor and have it detect farther.
What do you think would happen if your sensor were pointing west at sunset? Or kind of going in the right afternoon?
What do you
And it's
mean?
looking at well, so it's looking at IR, and so there's IR in
Yeah, so
Sunlight.
pretty much, I forgot to show you guys. This has an auto mode, but also has a manual mode. It's able to scan and pretty much it can scan the horizon.
So I'm just wondering how that might,
So pretty much it
Interfere with your
also,
detection.
it also detects the angles. So what you're saying pretty much is it will interfere. We have two different values, so it doesn't.
okay,
And pretty much it'll allow you, the user to get a generalization of what angle it's seeing the flame from so that they can go that way and likely they'll see the fire.
So I'm curious, what total voltage does it run on and what's the average power consumption for it?
Here, I can actually show you.
Oh, okay, so it gives you in real time what the total system power consumption is?
Yes.
Okay,
I believe these are the volts, the battery equals, and then the base.
oh, there it is, yeah.
Yeah.
Okay, so in my head, I'm trying to figure out what size solar panel you would need to run
Yeah.
fixed static versions of
Because we
these.
were trying with the simple battery packs, I noticed a bug with the little display. That's why I think we would need better battery packs if we were to show you a demonstration with the main unit connected to it.
When you put it next to the hood in the chemistry lab and have the fire and you trap smoke in the beaker, did you also, I saw pollen and humidity in the graph, but what about the CO2? You have this-
The CO2 module at the time was not working, so pretty much it kept displaying 400, which we all know that's not true.
Oh,
That's like the ideal conditions. So likely, I'm thinking on this module or on this prototype, the CO2 module is defective because we tried recalibrating it various attempts and it didn't quite work. Ideally, what we would do, since it's a cheap CO2 module, is we would replace it with a better one.
do you know what the range of your, the frequency range of your IR sensor is?
You mean how high it can go up to? Or
The wavelength.
I'm not quite sure.
There's certain ones that can detect, see the smoke and then also look through the smoke at
Yeah.
longer wavelengths to see maybe the flame.
Yeah. For this one, whenever we were testing the flames and there was smoke, it was still able to see it.
And then on a wildfire, I could see like in a building, the wheels and the mobility, but on a wildfire, how do you?
So pretty much what would happen is based on like the price of this, because it's a bit cheaper on the end of things, you would be able to deploy multiple of them pretty much in different areas. For example, next to buildings in forests, or for the people who do controlled burns, you'd be able to they would be able to use it to make sure that the fire is not being outpanned, and then they would be able to control the fire better. So whenever, for example, one area they detect a fire, they'll be able to alert the fire department and such to go to that area.
What about as payload getting it onto a UAV or drone, more on the prescribed burn or the wildfire, or taking samples along? That, or I'm just suggesting that might be a good,
Yeah, that would be a possibility.
wheels might be hard to move it around. On
Yeah, this is our previous project. So we added wheels because we thought about air quality. This one is for the fire, so it's able to use and be used in various situations.